Okay, so last set of notes. We are going to be looking at confidence intervals for sample mean. So let's just start with what is the formula. On the formula sheet, we talked about the formula is going to be in words. And so it is statistic plus or minus critical value times the standard error. That's what it says on your formula sheet. So we just need to be able to take that and put it into words, or put it into symbols rather. So our statistic is sample mean, so it'll be X bar. Okay, for critical value, I told you for proportion is always Z. Mean, 99.9% of the time, is T. So the vast majority of the time, mean will be T. And I'll tell you shortly the only time that you're going to use Z. And then lastly, standard error. Do you guys remember where to find that on the formula sheet? Okay, guys, maybe if your green sheet have something out. If you didn't get this, at least get your other one. It's on the back. On the back. So we have X bar. And we're going all the way over to standard error. And the standard error is S over root N. Okay. So you can use Z instead of T if you know sigma. So you will use Z if you know sigma. What is sigma? What is that the symbol for? Standard deviation. Which standard deviation? Your options are sample or population. Population. Yep. That's population standard deviation. Maybe write that down. Okay. Realistically, how often do you think we know the standard deviation of a population? Right? A confidence interval we're doing because we don't know the population mean. Do you think there are cases where we don't know the population mean, but somehow we know the population standard deviation? No. So realistically, this is never used. So theoretically, it's possible, but 99.9999% of the time you're going to be using T. Okay, standard error, that's what we wrote above. S over root N. Okay, next. We're going to talk about conditions, and then we're going to jump in. What are the three conditions for constructing a confidence interval for population mean? They are the same as before. And what I mean as before is they are the same three as proportion. What is the first one for proportion? Random what? Sample. What is the second one? 10%. Okay, I'm going to write that one third. We definitely need the 10% rule, though. Huh? Okay, N times P is how we check it for proportion, but what is that checking overall? Approximately normal what? Sampling distribution. So we need to have an approximately normal sampling distribution. Okay, here is the one that is tough. This is the one that's tough. For proportion, it's really easy. N times P hat, N times 1 minus P hat. That is not the case for mean. For mean, there are a few different ways. So you are going to have three options. If you're lucky, you will be told the population is normal. If the population is normal, the sampling distribution is normal. What is the other way to check that the sampling distribution is normal? You had this on your test. Greater than 30. What is that called? Central limit theorem. Yeah. So central limit theorem. That is when your sample size is greater than 30. Okay, go in this order. If the population is normal, great. If the central limit theorem applies, great. If not, your last one is you will look at a box plot or a graph of the sample. What you are looking for is no skewness or outliers. And then, lastly, what Kendall told us, 10% rule. Now, remember though, with the 10% rule, this is only when sampling is done. So we did that example 2 days ago where there was no sampling. If there's no sampling done, you don't have to check the 10% rule. So then the question becomes, what happens if one of the conditions is violated? If violated, we already talked about this, the actual capture rate of the true parameter will not be equal to the confidence level. In all likelihood, it would be less. Okay, we are going to do one example that goes through the whole process. Then we will take a break, and then you all will do an example. Do you have any questions for me? Okay. As part of their final project in AP Stats, Christina and Rachel selected 18 rolls of a generic brand of toilet paper to measure how well this brand could absorb water. To do this, they poured 1/4 cup of water onto a hard surface and counted how many squares it took to completely absorb the water. Using the data below, construct and interpret a 99% confidence interval for the mean number of squares of generic toilet paper needed to absorb 1/4 cup of water. Ooh. Okay, when we see construct and interpret, that's telling us that we're doing the 4C process. And it tells us in the question, mean. So you're going to have to be able to, when we get to the test, differentiate when it's mean versus proportion. Well, it should say in the question. Okay, so when we say choose, we are doing a 99% confidence interval. For mean, using T, and I'm going to leave myself a space because we're going to come back and we have to fill that in later. And then we're doing this because we're trying to estimate something. So we need to define the parameter that we are estimating. So we are going to say that mu is the population mean amount of squares of generic toilet paper needed to absorb 1/4 cup of water. Again, I don't really care where all of that goes as long as you have each piece written down. So then we need to check our conditions. First one, random sample. So it says they randomly selected 18 rolls. So random sample of rolls is chosen. The second one, we need an approximately normal sampling distribution Okay, what I'm going to write out in green is for your benefit only. You do not need to write this if you are actually doing the question. So the first thing you would ask yourself is the population normal? If that were the case, the question would directly state the population of number of squares required is normal. That's not stated, so we can't do that. Then you would ask yourself, can I use the central limit theorem? In our case, we have 18 rolls of toilet paper, which is not bigger than 30, so we cannot use the central limit theorem. So our last option is we have to look at the sample. This we are going to have to do on the calculator. So we will need to construct a graph of these numbers. We're not going to do that by hand. We're going to let the calculator do it for us. So what I'm going to ask you to do right now is go to your calculator and put all of those numbers into a list. As a quick check, once you have all of those numbers listed in your calculator, can you go to OneVar Stats for me? And let's just verify. You should get a sample mean of 24.94, and you should get a standard deviation of 2.86. Okay, so now that we have all the numbers in the calculator, what we're doing is we're looking at a graph of those numbers. So you're not going to see it up here. I'm just going to talk you through what you're doing. I want you to go to second stat plot and turn your first plot on. You can either construct a histogram or a box plot. I will tell you I choose a box plot always. So turn your first plot on and go down and choose the box plot that has the dots. It should say XList L1 frequency 1. Yeah, we got all that? Okay. How do we reset the window? Zoom 9, hit Zoom 9. And I end up with something that actually looks like very symmetric. Something like that. Can you check in with the people in your group? Show your calculator. If you didn't get that graph or you're stuck, help the people in your group, please. Okay, so this is our graph of the sample. What we are verifying is that there is not extreme skewness or outliers. We need to be very specific in the way we word this. So my expectation is that you draw the graph, and then you will write out, because the sample does not show extreme skewness or outliers, the sampling distribution is approximately normal. What I'm going to be very, very picky about, you need to indicate this is the sample, which tells us the sampling distribution is approximately normal. I will be very picky with the wording there. A lot of students will say something like, because it does not show, I will not accept that. Or because the graph, I will not accept that. It has to be the sample. Okay, third one, 10% rule. Our sample size is 18. This is one of those cases where I'm telling you, if you get the inequality wrong, don't write it. Because a lot of us are doing all of the work right, and we're writing a beautiful sentence, but we have the wrong inequality. So if you divide by 0.1, n has to be greater than 180. And in this case, we are sampling toilet paper rolls. So we are going to say, yes, there are more than 180 toilet paper rolls. Finally, we are at the calculate step. So we already wrote down the formula, x bar plus or minus t times s over root n. Now, this one is more difficult than proportion because we have to calculate x bar and s. Now, I already had you do that as a way to check your numbers, so we already know x bar and s. But otherwise, you would have to go back and do that yourself. Okay, so our x bar, we have 24.94 plus or minus. Leave yourself space for t because we're going to need to look it up. The s is 2.86 divided by the square root of 18. Okie dokie, t. You're going back to the same table we were at before, which is this table B. So either you have a table in front of you or you have it on your iPad. I don't care which one, but find it, please. Bottom, we're going to 99% confidence. Now, we know that number right above, 2.576, is z. We are not using z, though. We are using t. So the question is, which t value is it in that column? Along the left-hand side, you have what are called degrees of freedom. The degrees of freedom are always one less than the sample size. So if our sample size is 18, we're going to go to 17 degrees of freedom and then go all the way over to that 99%. And you should see 2.898. Do we? 2.898. Now, if you remember, in the very beginning of this question, I said, leave a blank next to the t. You have to say how many degrees of freedom you used. So, in this case, we're using t with 17 degrees of freedom. Like I said, it's always one less than the sample size. And then I will tell you this ends up being 22.99, 26.89. And lastly, you would write a conclusion. We're not going to do that because you've written a lot of conclusions already, but you have to write two different conclusions. You would write your sentence for the interval, and then you would write your sentence for the level. You're going to have practice in a little bit to do that, but that is something that really you've already done. Questions for me? Okay, I'm going to show you how to check your answer only on the calculator. So, next page. Can you use your calculator for the entire calculate step? Now? No. Later? Yes. And I'll tell you when we get to that later. It's not now, though. It's not going to be for a few months. Probably not going to be until May.
Oh my gosh, my iPad is at 10%.
Okay. So what I mean is, when I say you cannot use the calculator right now, you need to show a formula, a substitution, and then your interval like we did on the previous page. Then you will use your calculator to check. Your interval. So you will show all the work, the formula, substituting your numbers in, what interval you get. Then I'm going to show you the function on the calculator that will just do this for you. If you had to guess, where do you think you would go on the calculator? What is the button that we use a lot? Stat. Okay, so you're going to go to stat. So I'm going to write this list down, and I want you to follow along with me. So you're going to go to stat, and then you are going to go to tests. And you will see it has a whole bunch of tests. Z test, T test. We're not doing any tests, right? So those don't make sense. But when you get down to number 7, you will see it starts saying interval. So you're going to just keep going down for a little bit. And number 8 says T interval. You guys agree? You follow me so far? It says T interval. Okay, and then once you get into T interval, there's 2 options. There's data and there's stats. Data means the raw data is in the calculator. That's what we have here. You put in all 18 observations. Statistics means I'm going to input the sample mean and the standard deviation. So you want to highlight data. And it'll then say list, L1. You guys got that? Frequency is just 1. The only thing we have to change is the confidence level. We did 99%, so you're going to do 0.99, and then you'll hit calculate. And you should get the exact same interval that we came up with. Do you? Okay, so again, I want it all done by hand, but then you will go back and use the calculator to check your answer. Vicky. Yours is different. Okay, I will take a look at yours in a minute. So I want you to do this next example with the people in your group. You are doing the entire 4-step process, including the conclusion, both sentences, and you are answering part B. I do want you to check this on your calculator. So do all of the work and then use your calculator to check it. I'm thinking like 15 minutes is hopefully enough time. So that's what you have, 10 to 15 minutes. Good luck. But we're going to go over this. Did we get at least a good part of the way through? Okay. I'm going to show you my work. You need to make sure that you say how many degrees of freedom there are. So what I do is I write there's going to be 35, but then I saw on the table there's no 35, so I use 30 instead. I always round down so that my interval is a little bit too wide. Make sure you defined mu, and please make sure you have the word population in there. Population, mean, weight. In terms of assumptions, the random sample was stated. The sampling distribution was approximately normal by the central limit theorem. I will be looking for sampling distribution, approximately normal, and 36 is bigger than 30. And then the 10% rule. There needs to be more than 360 Oreo cookies in total. Here is the calculation step. When we did it on the calculator, we should have chosen stats, did we? Instead of data? Okay, and notice the intervals are very close. Not exactly the same, but very close. The reason that they're very close, but not exactly the same, this one uses 30 degrees of freedom, this one uses the actual 35. And then remember, I've worded mine a little bit differently. So you should have said something like, we are 95% confident that the interval this to this contains the population mean weight of an Oreo. Did we put units? Hopefully we did that. And then the level should have been something like, if we take many samples and construct confidence intervals for each one, about 95% will contain the population mean, blah, blah, blah. All that sound good? How do we feel about this? Okay, part B real quick. On the packaging, the stated serving size, 3 cookies, is 34 grams. Does the interval provide convincing evidence that the average weight of an Oreo is less than advertised? Less than advertised. I think what I saw a lot of us do is we took 34 and we divided by 3, which is about 11.3 grams per cookie. So 3.3. So is there evidence based on our interval that the average weight is less than what is advertised? No, in fact, what does our interval give us evidence of? That's more. Yeah, the entire interval is above 11.33. So that would actually provide us evidence that the mean weight of the cookies might be above what was advertised. We've got one last question to talk about. Questions before the last thing? Last thing, real quick, go to the next page, is calculating sample size. So that's what I want to do real quick. We're going to do this last example, and that'll be it for the notes. Administrators at your school want to estimate how much time students spend on homework on average during a typical week. They want to estimate mu at the 90% confidence level with a margin of error of at most 30 minutes. A pilot study indicated that the standard deviation of time spent per week is about 154. How many students need to be surveyed to estimate the mean number of minutes spent on homework per week with 90% confidence and a margin of error of at most 30 minutes? Okay, so we have margin of error. We want that to be less than or equal to 30. I told you that 99.9% of the time we use T. T, though, is based on sample size. Sample size is what we're finding. So it's not possible for us to use T. So instead, we're just going to use Z. So this is really the only time that you use Z. So we will use Z on the table because we don't know the degrees of freedom. So if I look up 90%, that Z value is 1.645. We then have a standard deviation of 154 over root n. So that's just the margin of error formula. I'm not going to show you the work. Hopefully you know how to solve that. You would get 71.31. And then like we talked about, I want to see that decimal and I want to see you round up. So we would need a sample size of 72 to maintain a margin of error of 30 minutes. We are done with notes. Congratulations, I'm equally happy.